Problem solution. Now we are going to solve some problems related to the groups. Problem number 1. Perform the addition operation on A equals to 0, 1. Construct the adjoining table and also check the identity and inverse elements if they exist. At the end, identify that whether A is a group, abelian, or non-abelian. Look, a non-empty set which is A has been given. A is a non-empty set because it has two elements, 0 and 1. It is a non-empty set. With what kind of binary operation? With the addition binary operation. So we will perform the addition binary operation on this non-empty set A. First to construct the adjoining table and then to check the identity and inverse elements if they exist. We will apply the identity and inverse laws to check the identity and inverse elements if they exist. It will happen after constructing the adjoining table. Finally, at the end, we are going to identify that whether A is a group, abelian group, or non-abelian group. We need to find the category of set A, which is a non-empty set, that whether it comes under a group category, or abelian category, or non-abelian. Let's go for it. First, to construct the adjoining table with the addition binary operation. So the elements of set A are 0 and 1. Here we have 0 and 1. So 0 plus 0 equals to 0. 0 plus 1 equals to 1. 1 plus 0 equals to 1. 1 plus 1 equals to 0. There we got the adjoining table with the addition binary operation. Remember, we have to use addition binary operation. Therefore, I put addition here. We already know about the adjoining table, that how to construct the adjoining table. For the set A, we have two elements, 0 and 1. So put 0 here and 1 here. So put 0 and 1 in the first row and 0 and 1 in the first column. Now to apply the addition operation. 0 plus 0 equals to 0. 0 plus 1 equals to 1. Now pick 1. 1 plus 0. 1 plus 0 equals to 1. 1 plus 1. 1 plus 1 equals to 2. But we know that according to the adjoining table, if the sum of the two elements equals to the total number of the elements, like the total number of the elements are 2, 0 and 1. So if the sum of the two elements equals to the total number of the elements, then you have to subtract that quantity from the total number of the elements. It also happens if the sum of the two numbers is more than the total number of the elements, then you have to subtract that number from the total number of the elements. I repeat it, according to the adjoining table, if the sum of the two elements equals to the total number of the elements are more than the total number of the elements, then we have to subtract that value after addition of the two elements from the total number of the elements. For example, 1 plus 1 equals to 2. So we have 2, which equals to the total number of the elements, because total number of the elements are 2, 1 and 2. We have two elements in set A. So we need to subtract that number which comes out after adding 1 to the 1 from the total number of elements. 1 plus 1 equals to 2. Total number of elements are 2. So 2 minus 2 equals to 0. 2 minus 2 equals to 0. We're going to put 0 here, not 2. Don't do mistake. Since 2 equals to the total number of the elements, so we're going to subtract that 2 from the total number of the elements. Total number of the elements are 2. So 2 minus 2 equals to 0. We're going to have 0 here. So there we got the adjoining table. Now to check the identity and inverse elements, that whether they exist or not. 1 plus 0 equals to 0 plus 1 equals to 1. So 0 is the additive identity. But what about the inverse elements, which is according to the additive inverse? At one side we have element, on another side we have additive inverse. So 0 is the additive inverse of 0. 1 is the additive inverse of 1. Because remember, 1 plus 1 equals to 2. 2 minus 2 equals to 0. Similarly, since 1 plus 0 equals to 0 plus 1, therefore it is an abelian group. It is actually a abelian group because it satisfies the commutative law. Look, first task was to construct the adjoining table. There we got the adjoining table. Second task was to check the identity and inverse elements. Identity and inverse elements. For the identity element, we will use additive identity, not multiplicative identity, because remember we have used addition operation, addition binary operation. We are not talking about the multiplication binary operation. Therefore, for the identity element, we will use additive identity law. According to the additive identity law, 1 plus 0 equals to 0 plus 1 equals to 1. Because remember, 1 plus 0 equals to 1 and 0 plus 1 equals to 1. 1 plus 0 equals to 1 and 0 plus 1 equals to 1. Which means that this element 0 is the identity element. Because remember, by adding 0 to both of the sides, you will get the same 1. It doesn't affect the value of 1 on either side of the equation. So 1 plus 0 equals to 1, 0 plus 1 equals to 1. Like ultimately it equals to 1. Therefore, this 0 is the additive identity. This 0 is called the identity element. Therefore, 0 is the additive identity of 1. It is the additive identity of 1, so we can say that 0 is the identity element. This is the identity element. But what about the inverse element? For the inverse element, we're going to use the additive inverse law. Why not multiplicative inverse law? Because the question asks that perform the addition binary operation. We are only performing the addition binary operation, So we're going to use additive inverse law, not multiplicative inverse law. We don't have multiplication here, we have addition. We have addition binary operation. So according to the additive inverse law, 0 plus 0 equals to 0. What will be the element that when you add to 0, it equals to 0? Obviously 0. 0 plus 0. 0 plus 0 equals to 0. So the additive inverse of 0 is 0. And also, what are the other two elements that when you add them, it equals to 0? Obviously 1 plus 1. 1 plus 1 equals to 0, because 1 plus 1 equals to 2. 2 minus 2 equals to 0. We're going to subtract 2 from the total number of elements. Total number of elements are 2. So 2 minus 2 equals to 0. So we can say that the additive inverse of 1 is 1. I repeat it. For the additive inverse, what are the two elements that when you add them, it equals to 0? According to this adjoining table, we have 0 at two places, here and here. It happened after adding 0 to the 0. 0 plus 0 equals to 0. And 1 plus 1 equals to 2. 2 minus 2 equals to 0. 0 and 1. We can say that this 0 is the additive inverse of this 0. And 1 is the additive inverse of 1. 1 is the additive inverse of 1. 0 is the additive inverse of 0. Because by adding 0 to the 0, it equals to 0. By adding 1 to the 1, it equals to 0. So we have two inverse elements, 0 and 1. Then finally at the end, we have identified that it is an abelian group. Because remember, it satisfies all the five laws, Closure law of addition, associative law of addition, additive identity law, additive inverse law, and also commutative law. If you try, it will satisfy all the five laws. If it satisfies the commutative law, then we can say that it is an abelian group. It satisfies the commutative law. 1 plus 0 equals to 0 plus 1. Because remember, 1 plus 0 equals to 1 and 0 plus 1 equals to 1. Again, I repeat it. 1 plus 0 equals to 1 and 0 plus 1 equals to 1. It is according to the commutative law of addition. So we can see that set A, which is a non-empty set, satisfies all the five laws of addition, because we have performed the addition binary operation. It satisfies the closure law of addition. Adding two elements of A belongs to set A. 0 plus 0 equals to 0. 0 is the part of A, which is 0. 0 plus 1 equals to 1. 1 is the part of A. So it satisfies the closure law of addition. It also satisfies the associative law, because A plus B plus C equals to A plus B plus C. It satisfies the additive identity law. It also satisfies the additive inverse law and commutative law. So we can say that it is an abelian group. It comes under the category of the abelian group. We got all the three objectives. First, to construct the adjoining table, which was this. Secondly, to check the identity and inverse elements. 0 is the identity element and 0, 1 are the inverse element, additive inverse element. The last objective was the category of the group. We got that it is an abelian group because it satisfies the commutative law. So that's what we have been asked in this problem. As I told you, by looking to problem number 1, you have to do your own analysis. You first check that does it satisfy the associative law? Yes. Does it satisfy the additive identity law? Yes, we just saw. Does it satisfy the additive inverse law? Yes. Does it satisfy the associative law? Yes. Because 0 plus 1 equals to 1 equals to 1 plus 0 equals to 1 belongs to A. Does it satisfy the commutative law? Yes. Because 0 plus 1 equals to 1 plus 0. Then we can say that A is said to be a group but an abelian group. It satisfies all the 5 laws: closure law of addition, additive identity law, additive inverse law, associative law of addition, commutative law of addition. 1, 2, 3, 4, 5. It satisfies all the 5 laws. Therefore, we can say that it is an abelian group. It comes under the category of group. There is no doubt it is a group. A will be the group, but an abelian group. There is subcategory of the group, which is abelian group. So it will be a part of group, but an abelian group. That's what we have been asked in this problem.